Jai Hind everyone. This is Manisha Rai, an assistant professor in Department of Computer Science and Engineering in Akgec Engineering College, Ghaziabad. In today's session, I would give some brief introduction about the Hadoop, like history of Hadoop, component of Hadoop, Hadoop ecosystem, Hadoop scalability feature, and the other functionality related to Hadoop. So one by one, we will discuss all these topics. So now let's start our presentations. First of all, this is the content related to the particular chapter. In a first segment, we will discuss history of Hadoop, then basic information related to the Hadoop file system. Then we will cover component of Hadoop. After that, we will discuss the scalability feature of Hadoop. Then we will discuss, this is the most important part, Hadoop streaming and Hadoop pipes. And in a last, we will discuss Hadoop ecosystem. So one by one, we will discuss all these topics. Let's start with the history of Hadoop. As you can see that here I have presented the one map related to the history of Hadoop. So we will discuss how developer decided to introduce the concept related to Hadoop and what is the benefit of Hadoop as compared to the relational database system. First of all, in 2002, the Nudge product was started. Hadoop was the sub-project of the Nudge. After then, in 2003, Google related white paper to the GFS. What is the meaning of GFS? It is the Google file system. And what is the white paper? White papers related to the research methodology. It means in a future Google will release or implement this concept in a practical manner. After that, in 2004, Google released white paper on MapReduce. Why we use MapReduce? MapReduce is a part of the Hadoop. After then, in 2006, the development of Hadoop started as the sub-project, and the later on, Hadoop was become the most important crucial project of the Apache. Then Yahoo was the first company who started the services of Hadoop to store its data in a distributed manner. And then from year to year, versions of Hadoop start releasing. The first version of Hadoop was released in 2008. And the latest version of Hadoop is released in 2024, that is the 3.4.1. So this is the basic history related to the Hadoop. After then, we are going to discuss what is the advantages of Hadoop and why are we using Hadoop. So the first important advantage of Hadoop is the cost. As compared to the relational database system, Hadoop require less cost or financial capital, because in a Hadoop we use distributed manner to data storage, and also it is required less hardware specification as compared to the relational database system. The next important advantage feature of the Hadoop is scalability. Scalability means in a Hadoop, if we need more hardware for the storage, so on-demand service. So with the help of on-demand services or scalability feature, we can enhance our hardware feature in the Hadoop. Then flexibility. Flexibility means as compared to relational database system is capable to store structured data, but Hadoop is capable to store structured, semi-structured and unstructured data. What is the meaning of all these data formats? Structured data format means here data is stored in the format of table. Unstructured data format means data is the combination, can be a combination of image, audio, video or any kind of the file. And semi-structured data means here we can collect the HTML data, XML data, JSON data, and other kind of data. So Hadoop is capable to store all these three kinds of data structure. Then the speed, as compared to traditional database system, Hadoop speed is much higher because it is store data in the distributed manner and took the help of data nodes. So data node is capable to increase the speed of Hadoop. Then fault tolerance. Why Hadoop is capable to provide the functionality or feature of fault tolerance? Because here we create replica of data. For example, if we took a one particular file and if the size of that file is on the higher side, so first of all Hadoop break that file into the block, or we can call this particular block in our data chunks. So that data chunks is assigned to the different data nodes and also is replicate that data nodes in the another data nodes. So if one data node is not capable to provide that service, so on that time we can take the help of the other data node to provide the services to the user. And these are some other advantages of Hadoop, like the high throughput and minimum network traffics. These are some common disadvantages of Hadoop. First of all, Hadoop is not much efficient to work on the small file size, and it's also vulnerable. Low performance in small data surrounding. Basically, it means that if we use the Hadoop to process or store the small file size, so it will be not that much beneficial. And for some time, Hadoop is also not capable to provide that much security related to the data of user. So these are some common disadvantages related to the Hadoop. Then here is the most important part of the particular chapter, is that is the Hadoop distributed file system. In a Hadoop architecture or Hadoop environment, there are three components are listed. The first one is the Hadoop distributed file system. The second one is the MapReduce, and the third one is the yarn. So we use Hadoop distributed file system to store the data, and also it is helpful to provide that particular stored data to the MapReduce for the process functioning. So this is the main work process of the Hadoop distributed file system. These are some following goals of this HDFS. The first one is manage large data set. As I have already discussed, HDFS is used to store and manage large data set. Then detecting faults. How it can detect faults? HDFS assign large file size, or we can say that it is divide the large file size into a small blocks and assign that blocks to the different data nodes. If one data node is not capable to process data or not capable to fulfill the request of the user, so on that time we can took the help of the other data nodes. So here we can say that in a HDFS environment, it is capable to check the fault tolerance of the particular data node, that on a moment it is capable to process the request of the user or not. And also it is hardware efficient. This is the architectural diagram of the Hadoop distributed file system. I am going to discuss that architectural diagram in a depth manner. So here you can see that this is the first block is related to the HDFS client. Here, what is the meaning of the HDFS client? It means user. That user who is going to use the services of the HDFS file. If a user want to read or write any file, so first of all, it will contact to the name node. Name node is store metadata of all files. Also it is store block information of file. So suppose with the help of an example, if a user want to upload a 1000 MB file on a HDFS. So what the name node will do? First of all, name node will generate a small kind of a data blocks of that particular file. Here the size of the file is 1000 MB, or in a HDFS the default size of a one block is 128 MB. So first of all, name node will divide that 1000 MB file to the 128 MB, and suppose if we get 5 or 6 block, so what the name node will do? Here name node will create 5 and 6 blocks in the different data node. Assume here if we get 5 data block, so in a data node 1, maybe Hadoop will assign, HDFS will assign data block A and data block C. In a data node 2, Hadoop will assign data node B and data node D. And in a data node 3, Hadoop will assign block E. So into that particular manner, Hadoop will assign different data blocks into the data nodes. And also that data node is connected to the local disk to fetch or store the files. So this is the basic architecture overview of the HDFS, that how it can process the file and how it will divide the particular large size of file into the different smaller data chunks. After that, in a HDFS architecture, we use one more component, that is the known as the rack. What is rack? Rack is available on a local disk. For example, if we user send a request to the name node to fetch a or to read a particular file, so what will name node do? First of all, it will distribute it or divide the particular file into the different smaller blocks and assign that blocks into the data nodes. Here in a data node 1, if we assign the data block A, B, C, D, E. So in a rack 1, we cannot replicate the same block again. If we want to replicate that block, so for that we have to take the help of the rack 2. In a rack 2, now we can replicate the same block again. Why we use that? Because we use rack to access the data on a local level. Here, when a client send a request to the name node, so first of all, name node will check the nearest available data node, and how it will find out the nearest available data node with the help of rack. So suppose if user want to access the data file D, so first of all, name node send the location of the data node to the client. If client is not able to access that block with the help of the particular data node, then again name node will send the location of the another data node that is available in the rack 2. So we use rack to store data in a locally. If one data node of the particular rack is not able to process the data block, so we can take the help of the another rack to process the data and fulfill the request of the user. So this is the basic purpose of the rack, that why we use that. After that, the next segment is the component of Hadoop. Basically, Hadoop environment is made up of the 3 components. First of the Hadoop HDFS, that is known as the Hadoop distributed file system, that I have already discussed. The second component is the MapReduce, and the third component is the yarn. Now we will discuss the working process of all these components. We use Hadoop distributed file system to store the data and to manage the data. we use MapReduce to process that data or fulfill the request of the user. For example, if a user want to read or write any kind of file, so for that we need processing, and here to process that data we use MapReduce. And the third component is yarn. We use yarn to resource allocation at the time of processing data. So these are the three major components of the Hadoop. Now, the most important feature of the Hadoop is scalability. Scalability means to enhance the storage capacity of a particular machine. Now, scalability are of two types. First one is vertical scalability and the second one is the horizontal scalability. First of all, we will discuss vertical scalability. What is mean vertical scalability? Vertical scalability means to add some new RAM or CPU to your existing system. For example, right now, whatever system you are using, maybe it can be your laptop, it can be your phone, anything. If you're not happy with the its storage capacity or its CPU, so you can replace your RAM with the extra RAM capacity. This is known as the basic feature of the vertical scalability. It means in a vertical scalability, we are not providing the on-demand service to the user. In a vertical scalability, we use existing system. Just in existing system, we add on some extra RAM or CPU to perform user request, and along with that vertical scalability has some limitation of the increment. After that, the next kind of scalability is your horizontal scalability. Basically, Hadoop use horizontal scalability to fulfill the request of the user. In a horizontal scalability, we are not use existing system to increase some RAM or CPU. Instead of that, in a horizontal scalability, we increase node or create some extra cluster to process the request of the user. So on a horizontal scalability, we do not follow any kind of limitation that how much node we can create to process the request or to process the data. It is totally depend on the on-demand services, that if a user demand larger size of a node, so according to his demand, in a horizontal scalability, we add further nodes and create further cluster to process his request. So this is the fundamental approach of the horizontal scalability. After that, the next important topic is the Hadoop streaming. To understand the Hadoop streaming, first of all, we have to understand the concept of the MapReduce. As I have already discussed, in a Hadoop, there are three major components are available. The first one is the HDFS, that is used to store and manage the data. The second one is the MapReduce. We use MapReduce to process the data, and the MapReduce program is written in Java. So ideally, MapReduce is designed to understand the file that is written in the Java code. But if we want to process some another kind of a file that is may not be written in the Java language, to process that file in the MapReduce, we can took the help of the Hadoop streaming. Hadoop streaming basically is work like an API. It will take the file that may be written in some other language apart from Java, and with the help of some syntaxes, we process that file in the MapReduce component. So that was the basic overall approach of the Hadoop streaming. These are some listed syntax that we can use to process another language written file in MapReduce architecture. Here you can see that some syntax is listed related to the Hadoop streaming, and these are some parameter description related to that syntaxes. After that, the main important part is started, that is the basic architectural diagram of your MapReduce, that how we can use MapReduce and what is the purpose of MapReduce. I have already discussed about the basic architectural diagram of the HDFS. Now we will understand the working process of the MapReduce. So in a MapReduce, first of all, what the MapReduce will do, it will take file from the HDFS and generate key value pair of that file. After that, I will explain how we can generate key value pair. Then assign that key value to the mapper. Now MapReduce is made up of the two different components. The first one is your mapper and the second one is your reducer. Then what the MapReduce do? MapReduce assign that key value to the mapper. Here the mapper read that key value pair and took the input and process that output in the form of the intermediate key value pair. That intermediate key value pair is assigned to the reducer. Now reducer take this intermediate key value pair as an input and process that intermediate key value pair and generate key value pair and assign that key value pair to the MapReduce component as an output format. So this is the basic work process of the MapReduce. Now I'm going to explain you how we can generate key value pair, intermediate key value pair, and finally we can get the output in the MapReduce working process. So here you can say that first of all, maybe we took the one file. That file have some data. For example, think that this file has the data river, ocean, sea, lake, river and sea, ocean, lake, river. That file is stored in the HDFS file system. Whenever we assign that file to the MapReduce, first of all, MapReduce will read that file and it will decide in how many chunks we can divide that file. So here, as you can see that MapReduce will divide that file into the three different data blocks. The first block will contain the data of the first line, that is your river, ocean and sea. The second block will contain the data of that second line, that is will lake, river and sea. And the third block will contain the data of the third line, that is your ocean, lake and river. Now MapReduce will process that file to the mapper. Here mapper will generate key value pair for the different data blocks. How the MapReduce will generate the key value pair? First of all, that it will read the data. It will read the data of the first block. So it will assume in a particular data block at least minimum one time the one block will be repeat itself. So in a first segment, the first data block is a river. So we assume that river will repeat at least one time. Then ocean will repeat itself in a one time in the particular data node. And sea also repeat itself at least minimum one time. After then, we will follow the same process like for a lake, repetition one time, river, repetition one time, then sea, repetition one time. Then for the data node 3, we again follow the same process. Ocean will at least repeat itself one time in a particular data node. Then lake repeat itself one time. River itself repeat one time. Then map reduce assign that generated key value pair to the shuffle. Now shuffle will generate an intermediate key value. How shuffle will do that? First of all, it will choose the unique data. So if it will choose river and check its repetition time, then again check where the river will repeat itself. Here river repeat itself, then assign its value again. Then check where the river repeat itself. Here the river repeat itself again. Again assign its value. Same do for the ocean. Ocean value 1, where the ocean repeat itself here. Then sea. Sea value 1, here the sea repeat itself again, and that's all. And for the lake, value first of all 1, and for the lake value 1. This is the working process of the shuffle. Shuffle will choose unique data from the mapper and assign its repetition value, that how many times it repeat in a different data nodes, and then forward that task to the sort. Now what the sort will do? Sort will do first of all assign a key, or we can say that treat that data, individual data as a key, and their repetitions number will be assigned as a value. Like river here treated as a key, and its repetition time, that is 3, is assigning as a value. For a ocean is a key, and its repetition time, that 2 as the value. Same for the sea will be the key, and repetition time it will be the value. For the lake will be our key, and its repetition time will be our value. So with the help like this process, now sort will generate the key value pair again and assign that key value pair for the further processing. So this is the basic scenario that in a Hadoop, how we can generate the key value pair. This is the basic function of the how streaming works. Like I have already explained, in a Hadoop streaming, first of all, MapReduce took a one input file and divide that into the different data blocks, then generate key value pair, assign that key value pair to the mapper. Mapper will took that intermediate key value pair and generate an intermediate key value pair. Now that intermediate key value pair will be worked as the input to the reducer, and reducer again process that data and generate the original key value pair and finally publish the original output. After that, the next topic is the Hadoop pipe. Like the Hadoop streaming, Hadoop pipe also following the same approach, but at the place of the bytecode, it will use socket, and it will use support C++ language to assign as a file to the MapReduce. Like in a Hadoop streaming, we can process any kind of a file. Maybe it can be written in any other language apart from Java. But in a Hadoop file, if any kind of file is written in the C++ language, to process that particular file in the MapReduce environment, we can take the help of the Hadoop pipes. And the last important topic is the Hadoop ecosystem. Ecosystem means on the different component, what kind of the real life tool we need to complete our work. Like here you can see that just to access the data in the Hadoop ecosystem, we can use scripting, SQL, ML, streaming, search. These are the basic function, and for that we can use that tool Pig, Hive, Spark, Storm, Source. Like for the execution, we can use MapReduce, Spark. For resource management, we can use Yarn. For data storage and management, you can use HDFS. For data ingestion, we can use Scoop and Flume. What is data injection? Data injection means to collect the data from the various sources. It can be our sources can be relational database or the web architecture. And for the operation and management, here are some listed tools are available. So in a short, the meaning of Hadoop ecosystem, it means to perform a different kind of a functionalities in a Hadoop ecosystem. What kind of a real life tools we are using to perform that task? This is the basic fundamental of the Hadoop ecosystem. With that note, I would like to conclude my topic. Thank you so much for giving your valuable time. Have a nice day.